let's talk about carbon dioxide. You hear two completely opposite things about it, right? On one hand, it's essential food for plants, a literal building block of life. But on the other, we're told it's a massive planetary threat. So which is it? Is it good or is it bad? Well, let's get into the science behind this whole contradiction. Okay, so here's the central problem. On one side, you've got basic biology. More CO2 in the air can act like a fertilizer for plants, making them grow bigger and faster. Simple enough. But then you've got the flip side. That exact same molecule is really, really good at trapping heat in our atmosphere. So it's kind of like a double-edged sword. So what gives? Which one wins out in the end? Well, the sources we looked at point to a pretty critical trade-off. Sure, plants might get a temporary boost for more CO2, but the extra heat that comes along with it, that's what ultimately stresses them out and can even kill them. So that initial benefit gets completely wiped out by the much more powerful downside. And this isn't just about plants, not even close. This whole heat situation throws our entire planet out of balance. It creates these huge, cascading consequences. So let's dig into how this one factor, excess heat, is fundamentally changing the world we live in. Think of it like a series of dominoes falling. It all starts when that trapped heat cranks up the temperature and humidity around the equator. That heat then moves and starts melting sea ice at the poles. But here's the really big one. The ice on land, we're talking the colossal ice sheets covering Greenland and Antarctica, starts to melt. All that water has to go somewhere, right? It pours straight into the oceans, and that's what makes sea levels rise everywhere. And this brings us to maybe the most critical part of this whole story, the speed of the change. You know, nature usually moves pretty slowly. Life takes tens of thousands, sometimes millions of years to adapt. But what have we done? We've crammed a mind-boggling amount of change into just the last 200 years. It's like we've hit the fast-forward button on the planet. And that's the real danger, right there, the sheer pace of it all. Evolution is a marathon, not a sprint. Plants and animals simply can't adapt this fast. They've spent millennia getting used to a stable climate, and suddenly, we've changed the rules of the game in what's, geologically speaking, the blink of an eye. So this isn't just about other species. As important as they are, this is about us. Our home. It's a direct risk to our own way of life. Let's talk about what this means for human habitability and this idea of a hothouse Earth. You know, one of the sources puts it in really simple, powerful terms. It says, we have a nice home to live in and are thriving, we just don't want to wreck it. And that's what it all boils down to, isn't it? Our civilization has flourished because the Earth's climate has been incredibly stable for thousands of years. The argument is simple. Let's not break the one home we've got. So how exactly does this threaten us physically? It comes down to our biology. As mammals, our superpower for cooling down is sweating. But here's the catch. Sweating only works if that sweat can evaporate off your skin. When it gets super hot and super humid at the same time, the air is already full of water. Your sweat just sits there. Your body's built-in air conditioning system just breaks down. At that point, the environment can become literally unsurvivable. And beyond the direct physical threat of the heat, you've got massive social problems brewing. Remember all that melting land ice? Well, rising sea levels are going to force huge numbers of people who live on coastlines to move. We're talking about mass migration, which the sources suggest will lead to intense competition for land, water, and resources. Now, the source material also brings up a term you've probably heard, greenwashing. The way it's defined here is pretty specific. It describes when, for instance, a fossil fuel company captures CO2, but then uses that same CO2 to help push more oil out of the ground. The process might get labeled carbon neutral, but the perspective in the source is that this approach is really just prioritizing short-term profits over genuine, long-term climate solutions. Okay, so we've laid out the scale of the problem, and it's a big one. But what can we actually do about it? Let's switch gears and talk about the solutions, about the path forward to what's called net zero. The main goal here is incredibly ambitious, but it's also crystal clear. We're not talking about just cutting back a little bit. The target is net zero. And what that means is getting to a point where we are not adding any extra carbon to the atmosphere. Anything we put in, we have to take out. And the timeline for this? Basically, as fast as humanly possible. So how do we get there? Well, the sources outline a kind of three-part strategy. First, we have to go all in on renewables. We're talking solar, wind, and the battery storage to back it all up. Second, we need to get serious about carbon capture technologies that can literally suck CO2 right out of the air. But the theme underlying all of this is urgency. The big takeaway is that making this switch as soon as possible is our absolute best hope for keeping our planet livable.
And so, when you put it all together, the paradox, the very real consequences, and the solutions on the table, it really leaves us with one big final question, a question posed by the source material itself. What legacy will we leave behind? Something to think about. Thanks for joining me.